time. This is important, right? A hint, right? I'll give you a hint. So now I want to talk about source follower, which will be the power stage amplifier, the power amplifier. But at this point, look at this. I've emphasized it, not a power amp yet, okay? I still treat it as a small signal. I just want to analyze it as a small signal. As a hint, you need to understand very well what I'm talking about here. And then, however, we have a very small load, okay? So I want to see how it performs. What is the gain of a source follower? Do you remember? If you forgot in the interview and you forgot the equation, at least you should tell approximately what should be the gain of a source follower. What is the meaning of a follower? Just give me an approximation. No need to think about the equation, right? Remember what we said about follower? Like the younger brother follow the older brother? Yeah, the input is the same as the output, except it is shifted, right? So what is the gain of the AC? AC gain, right? One. This is something, what I mean by the basic concept, right? It's okay you forgot the equation, but in the interview, we really need to be able to say that, right? But if you have this in your cheat sheet, or if you can Google, I think in the future, in the interview, it might actually ask you, what would you do? How would you ask ChatGPT if you need to find a question?
Which construct chat design was
I have a problem again here, so I need to save it.
Yes, ChatGPT how to fix the problem with your computer.
No, I haven't.
No, not recommended by the AP.
But ChatGPT is really good. On Facebook, I have a friend said that he tried to claim for insurance, write a complaint letter, and then he just asked ChatGPT to draft it, and then it was successful. And so that save a lawyer's time and money. Yeah. Yeah. So
Particularly trained on.
okay. Anyway, so this is the gain, right? When GMRL is very large, then the gain is approximately equal to 1, right? We derived this before, okay? So go back to study. But you should have this in your cheat sheet, right? This is a source follower. My question is, what should be the GM to make it a good source follower? Again, as just I said, a good source follower, you need a large GMRL, right? Because if GMRL is small, then your gain is no 1. So for example, I want it to be, let's say, larger than 10. This is the requirement, right? Even it is 10, then I only have 0.9 about, right? The gain instead of 1, because 10 divided by 11 is about 0.909 something, right? So I want it to be 10, right? So it's just like a question I ask you, okay, then what should be the GM of this transistor? Okay, so now I say because this is the requirement, I let GM RL equals to 10, okay? And first of all, what is GM? GM, you check the cheat sheet, right? Or if you remember, there are a few ways to do that. You can say GM equals to W on L mu C ox times VGS minus VT, right? Or what is the other equation? It can be ID, right, times W on L mu C ox, and then maybe times 2 squared. I think I'm right. I don't have this in my cheat sheet, but this is a hint. Right? If you get the ID, you should know how to find the GM, right? But here, I am going to use this equation because what I'm given is this. GM is equals to W on L. What do I have? Actually, I need to choose W on L. I'm the designer. What is mu C ox? It's given here, right? times 100 mil. And then what is VGS minus VT? I should have gave you here, VGS equal to 1.4 and VT equal to 0.4, right? So it's 1.4 minus 0.4. This whole thing is the GM. And then I times 8, I want it to be equal to 10. Is that okay? Yeah. So if at a certain bias, this is small signal, right? So I assume it is at certain bias. For example, when this is 0, right? And then all the current will go through M1, right? So you just solve the equation, W on L, right? You just solve it. Let me just make sure that I'm correct. Actually, I'm wrong in here. I'm sorry. This is not 100 because what I'm giving you here is the PMOS. But this is the NMOS, right? So mu NCOS is 200. So is that okay how I get this number? I'm a little bit messy, but do you see that? Because this is given, right? 200. 1.1 minus 1.4 times this equal to 10 times 8, right? GM times RL equals to the gain I want. I want it to be large. You can even make it larger, but too large is not good. But this is very large already. Turn out to be 6,200. Now, if you have L equals to 1 micron, assume that you can only use L equal to 1 micron because this also related to the breakdown. So it really depends on your application. Then what should be the W? What should be the W when L is 1 micron? Yeah. So what is that? It needs to be 6,200 micron. And what is this? 6.2 millimeter. So you're talking about I need to have a device that is 6.2 millimeter that you can see, no need a microscope, right? In power amplification, this is very common for high power handling, okay? But here is not for that because this is for small signal model. I just want to say that if you still want to keep the small signal model, right, with this gain, you need a very large transistor. So this is just ridiculous. It's just that the low of the device is too low. I just want you to see that 8 ohm is really low. It's not a good low for a voltage amplifier. Okay. So, but just a feeling, right? No use actually. We are not going to use this, but you should be able to calculate this at least. A hint. Okay, so if there is